Welcome to Lesson 34, where three little letters unlock the entire world of remote computing. Picture Mia. She's just rented a cloud server for $5 a month, sitting in a data center somewhere in Frankfurt. The provider sends her an IP address, a username, and a key file, and now she has to actually use this machine that's 1,500 kilometers away. That's where SSH comes in, Secure Shell, the foundation of every cloud workflow you'll ever touch. So what does SSH actually do? At its core, it opens an encrypted tunnel between Mia's laptop and that server in Frankfurt, and once she's through, the shell she's typing into is the server. When she runs ls, she sees the server's files. When she runs apt update, she's installing packages 1,500 kilometers away. Every keystroke, every response scrambled end-to-end. Nobody on the coffee shop Wi-Fi, nobody at her ISP can read a thing. And when she types exit, she's quietly back on her own machine. So let's actually try it. The pattern is simple: SSH, then your username, an @sign, and the server's address. The very first time you connect, SSH pauses and shows you a host fingerprint, asking if you trust this machine. You type yes, enter the password, and suddenly the prompt shifts, from learner at Dargslan to Thomas servers at 01. That little change is your visual cue. You're not on your laptop anymore. You're inside the server. And when you're done, exit drops you right back home. Now typing a password every time gets old fast. And honestly, it's the weakest link. So let's upgrade. Key-based authentication works in 4 small steps. You generate a key pair on your laptop, copy the public half to the server, connect, and then lock down the private half with strict permissions. The golden rule here is worth tattooing somewhere safe. Your private key never leaves your machine. The public one you can scatter across every server you own. If the private key ever leaks, treat it like a stolen password. Regenerate, replace, move on. Once you're past the basics, 3 little flags do most of the heavy lifting in the real world. -I points SSH at a specific private key, handy when AWS hands you a fresh .pem for every server. -P changes the port because plenty of admins move SSH off the default 22 to quiet down the bots, and -V turns on verbose mode so when a connection silently fails, you can actually watch where it breaks. And once you're tired of typing all 3, drop them into bod ssh-talk config and just type ssh my server. Let's watch all of this come together with Mia. She's just rented a small VPS, $5 a month, somewhere in a Hetzner data center, and the provider has handed her an IP address, a root user, and a private key. First move, lock down that key with chmod 600 because SSH will refuse to use it otherwise. Then the first connection, she points at the key with -I, accepts the host fingerprint once, and just like that, she's inside Ubuntu 24.04. A quick hostname, uname, and uptime confirms she's really on the new box. An apt update brings it current, and the server is live. Now that chmod 600 step Mia did so casually? Skip it and you'll meet the most famous SSH error in the wild. Warning: unprotected private key file. The default permissions on a freshly downloaded .pem are usually 644, meaning anyone on the system can read it, and SSH simply refuses to touch a key that exposed. It's strict, almost stubborn, but it's protecting you from yourself. The fix is one line, chmod 600 on the key, owner only, no group, no others. Download, lock it down, then use it. That's the rhythm. Rarely travels alone. Around it lives a small family of companion tools that turn one-off logins into a real workflow. ssh-keygen is the forge. It creates your key pair, ideally with the modern ED25519 algorithm once for years of use. ssh-copy ID is the courier. It installs your public key on a server without you ever hand-editing authorized keys. And SEP, which we'll meet properly in the next lesson, carries files through that same encrypted tunnel. Same auth, same trust, different jobs. Now it's your turn to feel this in your fingers. 3 small steps. First, forge a key pair with ssh-keygen-t ed25519 Defaults are fine, no passphrase is okay for practice. Then cat your public key and notice that single line starting with SSH ed25519. That's the string you'd hand to any server. And when you're ready for a real handshake, SSH demo at test.rebex.net, password. It's a read-only public playground, poke around, type exit, and you've just done the whole thing end-to-end. And just like that, lesson 34 is complete. You've got a shell on any machine in the world, secured by keys you minted yourself. But SSH only gives you a shell, and sometimes you need to move actual files across that encrypted tunnel. That's where we're headed next. SCP, secure copy, the finale of stage 07. Same handshake, same encryption, just files instead of a prompt. See you in lesson 35.